Okay, so today we are covering solving rational equations. We're taking what we've done the past few days, putting it together to solve equations and get an answer, a simple answer for x. So your bell ringer questions should be finished by now, so we're going to look at those. So the first one is solving complex fractions. We did that yesterday. So we have to get a common denominator on the top as well as on the bottom. So we got to get those separately. So these are over 1. And it looks like we need a y on the bottom. So we're going to give ourselves a y for this one. Okay, then my top is going to be this then. We have x, y plus 5 over a y. And then we do the same thing on the bottom. We're looking to get that y on the bottom. So y here and here. And then similar to the top, now that we have the common denominator, we can add the stuff on the bottom, put it together in a single fraction. So there's our fraction line, and we're going to have y plus x over a y. Then, since we have those two fractions combined, we take the bottom one and we move it to the top, and we're going to flip it. And then we can make that x plus y or y plus x. Either way works. Okay? Once we have moved this, we did our skip, flip, multiply, we're looking to cancel things. So if we look here and the bottom over here, those are not exactly the same, so we can't cancel them. But we do have a y that we can cancel out. So our final answer is going to be xy plus 5 over y plus x. And if you like that, write that as x plus y. That might look a little bit better. That's fine. That is our answer. Okay, next one, you should do division. So what we should have done here, we had a question similar to this a few days ago. We have to factor as much as we can, and then it's exactly the same thing as what we just did with our complex fraction. Since it's a division, we skip, flip, multiply. Okay, so I'm just going to factor these right above them. So this one right here, that's perfect cubes. So remember, we cube root this and we cube root that, and we're going to get x plus 4. And that's the little set of parentheses. Remember, this is our SOAP method. So then we take the x, square it over here, take the 4, square it and put it in the back, and then the middle is going to be 4x. That's both of those. And then remember our signs. They're same, opposite, always positive. So that one's factored out. Okay, denominator. This one, you're going to take a couple steps to factor that. So take a 2 out, and then we have x squared minus 16. And then this one right here, that's difference of squares. X squared is the perfect square, 16 is the perfect square. So that'll turn into x minus 4, x plus 4. Okay, so that one's factored out. And maybe we'll write these off to the right so they look a little bit nicer. So x plus 4, and then x squared plus, minus 4x plus 16 over 2x minus 4, x plus 4. And now we'll factor these, but we're going to flip them when we write them out to the right. So if I factor this one, that's going to be, so two numbers that multiply to 16 and add to 4. So that should be an 8 and a 2, nope. 4 and 4, nope. So this is the one that we can't do. There's no way to factor that, all right? So remember, you could run into that. So we're just going to rewrite that one. And then this one we can factor to that. And since we're dividing, we flip them. So we have the 2x plus 6 going on the top, and then the other stuff going on the bottom. And then we multiply because we flipped it. So remember, we ran into this the other day where that stuff couldn't be factored, which kind of worked in our favor because now we can cancel those out. And then we have an x plus 4 to cancel, and then we can cancel out that 2 as well. So our final answer, we have an x plus 6 on the top, and then an x minus 4 on the bottom. Okay? If you need to rewatch these again later, they will be in Canvas. So starting with the lesson today, we're looking at solving rational equations. It's going to have a very similar feel to what we've done the past few days. So starting out, you have these steps. We're going to find our least common denominator of everything. And then we're going to multiply everything by the least common denominator. Okay? So I'm going to show you a couple different ways to do this, and you choose whichever one you want you think is the easiest. So you have to find a common denominator regardless. Okay? And we will solve what we have in the end. So if I'm looking at this, I look at my denominators here, here, and here. All of them, every single denominator in the question. And we want to figure out what's the common denominator, which this one should be fairly straightforward. Between 5, 2, and 5, my common denominator is 10. So I can multiply everything in this equation by 10. So 10 over 1. Okay, so I'm multiplying this by 10, multiplying this by 10, multiplying this by 10. And just so we can see that for each one, if I multiply this by 10 over 1, we can see the 5 and the 10 are going to cross cancel. So that would turn into a 1, that turns into a 2. So what I have left here is the 4x times 2, which is 8x. All right, doing the same thing here. So we have 10 over 1 times this. We cross cancel, that turns into a 1, that turns into a 5, so that turns into 15. And then we got to do it one more time over here. So times 10 over 1, cross cancel, that turns into a 1, that turns into a 2, and we're going to have to distribute that 2 here because we have multiple things up there. So that would just be 2x plus 2. And then you can finish by solving this. This should be fairly simple to solve after you got this first step. So that's the general way to do it. We have to finish that out still. But let me show you maybe a better way that you might like a little bit more. Okay, so if I am working on this, so I'm going to get that common denominator for every single fraction. Once I get the common denominator, it'll just cancel out. So if I took this one times a 2 to get a 10 down there, I'd have to take this one times a 2, which gets me 8x. I'd have to take this one times a 5 to get that 10 on the bottom. Okay, so 3 times 5 gets me 15. And I'm going to have to take this one times 2 to get that 2 on the bottom, or get that 10 on the bottom, excuse me, and that's where we get that 2x plus 2 from. Once you get the same thing in the bottoms, everything cancels out. Okay, that might be a better way. I think I like that way a little bit better, so I'm probably going to stick with that one. But now we just need to finish solving here. So let's get the x's on one side. Okay, so let me write my work over here. So we have a 6x plus 15. And then we have a 2 on the right. So let's get the constants, the regular number, on the other side. So 2 minus 15 is negative 13. And then we got to divide by 6. So x equals negative 13 sixths. Kind of an ugly fraction, but that's what we got. Okay? So either method, whichever one you choose to do, I like this one a little bit better just because it seems a little familiar to you guys. But that's what I like to do. All right? Next question. So if you want to try this one, you can pause the video. Otherwise, we'll keep going. So we need to get our common denominator between all of those, and the denominator will be a 4. That should be a pretty easy observation. So the only thing we need to fix is this right here. So we're going to have to take this one times the 2 on top and bottom to get that common denominator. And once we do that, we're going to have a 4 here, here, and here. Those will all cancel out. So we're just going to have 3x plus 2 equals 2x minus 3. Put the x's on the left and the numbers on the right. So we have an x on the left and a negative 5 on the right. And that one is done. So that one doesn't take much time at all. Okay, so looking at number 3, we're going to do this one together. So now we have to think about how we get denominators when there's variables, just like what we did yesterday and the day before. So if I have an x here and a 5 here, then I'm going to have to get 5x on the bottom. So my 3 just has a 1 below it. Okay, and maybe you want to write your common denominator off to the side like this. Like I've told you guys in the past, we have to get a 5x in the bottom. So this one here, the 3, is going to have the 5 and the x. So we're going to multiply by 5x on top and bottom. Okay, this one just needs the 5, so we're going to take it times 5. Okay, maybe we can write these numbers as we go. So this will be 15x, and we know that the bottom is going to cancel out, minus 10. And then this one just needs the x. So equals x. So we got our 15x here, or excuse me, we got our 5x here, 5x here, 5x here. So once you have that common denominator across the board, it cancels out because we'd be multiplying by 5x to get rid of it. Okay, so then from here, you got something much more simple to solve. And if we want to keep doing the way we did it before, we're going to put the x's on the left, put the number on the right. So let's move this 10 over here and move the x over to the left. So we'll have 14x equals 10. And then we'll have to solve this. So divide by 14, and then simplify that down. So what can we take out of 10 to 14? It looks like just a 2. So reduce it down, we get x equals 5/7. Okay? So it wasn't really much more complicated with a simple variable down there. You do it the same exact way, but you just have to take into consideration that x and the number. Okay? So try number 4 and number 5. So if you would like to pause the video and work through these for a few minutes and then start the video back up and have kids look at their solutions and check their answers. Okay, so first one, this is over 1. Same thing down here, that's over 1. And that's over 1. So I would put everything over 1. That way I can kind of get my common denominators. For this one up here, we need a 3 and an x. So this is the denominator that we need. Okay, so the first one is missing both the 3 and the x. So times 3x. This one has the 3x, so we don't have to take it times anything. It's already a common denominator. And this one is missing the x. So we're going to multiply this by x. When we do that, the bottom goes away. And then we have to just simplify out the top. So this one over here is going to be a 3x squared. And then we'll have minus 4 equals negative x. All right, so hopefully you got that. Now, to finish this one out, whenever we have a squared term and a regular term, we're back to the stuff we did at the end of last chapter where we're going to have to factor it out. So let's put everything on one side. So we're going to move this x over. And we have to have it in the correct order, so that's standard form. And now we have to factor using SMILE method. Okay, so to get the 3x squared, we're going to have a 3x and an x. To get the 4 in the back, we can use a 4 and a 1 or a 2 and a 2. I would use a 4 and a 1, putting the 4 here and the 1 there, because that gets me 3x and 4x, which we can use to get the positive 1x. Okay, so it looks like the 4 is going to be the positive, the 1 is going to be the negative. And we're almost done, because just like the last examples, we have to finish this and get an x equals something. So how do we get x equals from something like this? Well, you're going to have to set those equal to 0. Okay, so this one, if I solve that one, we get x equals negative 4/3. And this one, if I solve that, I just get x equals 1. Okay, and when we're doing these, one thing to consider, I'm going to kind of go back to our original question. All right, we have to take into consideration what values we can't have down in the bottom. Okay, because those are called domain restrictions. We still have to consider those. If one of our answers over here turns out to be the domain restriction, then we're going to have no solution, or it's just not going to work. So the number you can't have here would be a 0. I can't put a 0 in for that x, because that would make the whole thing equal 0. So x cannot equal 0, which neither one of these is a 0, so we're good and we have our answers. Okay, so just kind of keep that in mind. So let's check out the next one. All right, so I just need an x in the bottom. So this one doesn't look too bad. The only thing I need is an x. So I need an x here, which if I'm taking the top times an x, that gives me x squared. I already have the x here, so I'm just going to put my minus 6. And then over here, I need an x on top and bottom. So that'll equal negative 5x. And just like the last one, we're going to have to put everything on the same side and factor. So move this over. And then factor. So two numbers that multiply to 6 and add to 5, that would be a 3 and a 1, or excuse me, 3 and 2, or a 6 and a 1. And it looks like the 6 and the 1 might be the combination we want. So we want a positive 6 and a negative 1. And we have to finish these out, set them equal to 0. X equals negative 6, and x equals 1. Okay? And again, those answers are probably going to work because we just can't have a 0 down here. All right. So we got a few harder examples, and then we'll be done. All right. So these ones, just like what we did yesterday and the day before, the harder examples, you're going to have to factor first to see what your denominator is going to be. So the stuff on the left here, this one, that's both perfect squares, okay? And sometimes you can look at this and figure out what that's going to be. Okay, you can kind of use the question to do the question, if that makes sense. So this is going to factor to x minus 3, x plus 3. So if I'm looking at this denominator and these, I need both an x plus 3 and an x minus 3 to be the common denominator. Again, if you need to write it off to the side, you can, but this is what we need in the bottom. Okay, so the thing that's missing here, like this one's already good. It has both of them. So the thing that's missing here is the x minus 3. So we need that here. And then the thing that's missing here is the x plus 3. Okay, so again, we know the bottom is going to cancel out, so we don't have to do anything with the bottom. Now we're just working across the top to simplify. So this one, I have that 4x left on top. And then this one, we're going to have 2x minus 6, because we have to distribute the 2. Okay, and then equals, we distribute the 5, so it'll be 5x plus 15. And then that should be a much simpler question than what it appeared to be in the beginning. And we don't even have to factor on this one because we didn't get any x squareds. So let's just simplify and solve. So on the left, I have a 6x minus 6. On the right, 5x plus 15. Put the x on the left. Put the 6 on the right. And we'll get x equals 21. Okay? And you should be able to check these. They're kind of a bear to check. It's not very fun. But if you plugged in 21 to everything, it would end up working out. And remember the numbers we cannot have. They would break it. We cannot have 3, and we cannot have negative 3. But we got a 21, so we're good. All right. Next one should be similar. Let's give it a shot. So again, we can look at this and this. If we forget what difference of squares patterns is, that should kind of bring your memory back. I got 2 squares here. So x minus 2, x plus 2. And so that looks like that's our denominator. So we need an x plus 2 here, x minus 2 here. And then the bottom is going to cancel out, and we can just solve. So we'll have a 3x plus, so that 1 will distribute, just making that an x plus 2 again. And then the 2 will distribute here, so it'll be 2x minus 4. Put everything together. So on the left here we'll have 4x plus 2, and then 2x minus 4. And then put the x on the left, number on the right, so we'll have 2x. We're subtracting 2 from that, equals negative 6. And then divide by 2, x equals negative 3. And it looks like we are okay because the numbers that we cannot get would be a 2 and a negative 2. Okay? So if you have something simple. So we went from this stuff here. This is kind of difficult stuff. All this stuff is, you have to factor and get common denominators and all that stuff. So that's kind of difficult. If you have something like this, you should remember from geometry. So this is just a simple fraction on the left, fraction on the right. You've done these before. You simply cross multiply. So what that means is I'm going to take this times this, okay, and I'm going to set it equal to those two times each other. If you think back to middle school, you guys learned this stuff forever ago. It was called fish method because people would multiply and divide and you have your fish there. It doesn't work as well when you get to higher order or higher level math because you have more x's floating around. If you just had one x, it would work easy. So we're going to take this times this, and then we're going to set it equal to this times this, so which is 30. Okay, so set those two equal to each other, and then you got something that you can solve. So x squared and an x, what does that mean? Means we need to factor. So move the 30 over. Two numbers that multiply to 30 and add to 1. It's going to be a 6 and a 5, and we're going to have that be a negative 6, positive 5. And then you set those equal to 0 to get your two answers. X equals 6, x equals negative 5. Two answers, they should both work. Okay? So one more of those. And if you wanted to pause the video, try this on your own, go for it. Okay, it looks like we're going to have a little bit higher power variables. So if we're multiplying these, that gives me x to the third minus 6x squared. And then we're going to multiply these. So that'll get us 36x minus, and you might want to get a calculator out, that should be 216. And so we got a cube. Well, that'll complicate it a little bit, but we're going to try to put everything on the same side and factor just like we did on the last one. So move the 36x over, move the 216 over, and I'm guessing that we might be able to factor this by grouping. So split it, take an x squared out of the front, x minus 6, and we're going to take a negative 36 out of the back, and we'll get x minus 6 again. So this is just factored by grouping. You look and see what we can take out of the front and the back. So we have x minus 6 is the same, so those go together. And then we have x squared minus 36. And then, so this one we can keep going. So that gives me x minus 6, x plus 6. And then we have this other x minus 6 in the front. So set all these equal to 0. And it looks like we're just going to get a 6 and a negative 6. You don't need to write the regular 6 twice because it's in there twice, but that's how we do that. And if we look at this, so kind of going back up here, this is one of the cases we talked about. Do both of those work down there? No. That 6 does not work. So your only answer is negative 6. Okay? So that sums up today's lesson. We went through solving rational equations, getting common denominators, adding, subtracting, factoring, all of that stuff in one lesson. So this video will be in Canvas for you if you need it, and you can also email me if you have questions. So your homework is the assigned worksheet. Good luck. Let me know if you have any questions.